This video is on dilution. So we're going to talk about how to make a dilute solution from a more concentrated one. So what dilution is what I just said. It's using a more concentrated solution to prepare one that is less concentrated. So I do this all the time in lab when I make, for example, your hydrochloric acid solution. So in lab, lots of times we use 6 molar or 1 molar or moles per decimeter cubed solutions. And the stock solution that I buy is 12 molar, 12 moles per decimeter cubed. So I have to dilute it. So all you do, or is all I do, is add water. So water is added to dilute the more concentrated solution to the lower concentration. So equation-wise, what we need to understand is when we're adding more water, we are only changing our volume of our solution. So what I mean by that is if you're going from solution 1 to solution 2, we are just changing the water. So the volume will change. The moles will not. We're not changing our solute. So our moles of our solute, there we go, will be the same for both solutions. But the volumes will not. So volume of 1 does not equal the volume of 2. But we can use this part right here to help us determine kind of how much water to add. So we got to go back and remember this, that our concentration is our moles over our volume. So if I solve for moles, right, if I move both sides of volume from one side to the other, I find that moles are concentration times volume. So I can replace moles with C times V. So the concentration of solution 1 and the volume of solution 1 will equal the concentration of solution 2 and the volume of solution 2. Right? Like I said, the volumes won't equal each other, neither will the concentrations. But when you multiply them, you will get two values that will be equal because those are your moles. So this is my formula or my equation. And when it comes to like more concentrated or less concentrated, which one is 1 and which one is 2, it doesn't matter. All that matters is you have the right volume with the correct concentration. So let's go through an example here. All right, so it says what volume of 7.5 moles per decimeter cubed sodium carbonate solution is needed to produce, and I'm going to change this number, you should too, to 100 centimeters cubed of a 0.45 moles per decimeter cubed sodium sulfate solution. All right, so we got all these numbers. What do they mean? So let's see, 7.5 moles of sodium sulfate, what volume? So I'm trying to find that volume, and I know a concentration. 7.5 moles per decimeter cubed. And I'm wanting to produce a new volume, 100 centimeters cubed. And a new concentration. All right, so I hope you can tell that these first two go together. What volume of that 7.5 mole per decimeter cube solution? So I'm going to label both those 1. I could make them both 2, but I just need to know that they go together. And then my new volume is 100 centimeter cubed of this concentration. So now here's where, if you remember, I like to do my algebra without my numbers in there. So I'm going to rewrite my equation. And I'm going to solve for V1. So if I divide both sides by C1, I find that V1 equals C2 times V2 over C1. And now I can plug my values in. So, oops, too far. So I've got 0.45 moles per decimeter cubed times 100.0 centimeters cubed. And if you're thinking, hold up, decimeters cubed, centimeters cubed, it's not going to cancel. Just wait. Because I'm going to divide this all by my C1, which was 7.5 moles per decimeter cubed. So now looking at this, I can see that my moles per decimeter cubed, my concentration units, are what are going to divide out. And the unit I'm left with is centimeters cubed, which is a unit for volume. And that's okay, unless my problem asks for the the volume in decimeters cubed, I don't have to change that. So now it's just a matter of typing it in. 0.45 times 100 divided by 7.5. So I find then that my volume is 6, and I'm going to give it 2 sig digs because of the 0.45 and the 7.5. So 6.0 centimeters cubed. Okay, so what does this all mean? That's the second part. Okay, how do you make this? So you're like, okay, great, I can do the math, but what if I told you now, okay, now go make it in the lab? What would you do? All right, so here's what I do. I need one of these. Let's see if I can draw it. All right, we're going to say close enough. Remember, this is your volumetric flask. And this will have a line on it that will tell you the volume that this holds. So I would find the one because I want to make 100 centimeters cubed. That's the volume I want. That's 100 milliliters. I want to find one that has a line right here on it at 100 milliliters. All right, because that's my total volume. So what do? Well, I look at my more concentrated one. My more concentrated is my 7.5. So how much of that one do I need? Well, that's what I calculated right here. 6 milliliters or 6 centimeters cubed of my 7.5 concentrated solution. So step number 1 will be to add 6 milliliters of 7.5 moles per decimeter cubed sodium sulfate solution to the volumetric flask. All right, so that would be, right, I would add this little bit right here. Okay, so second step, all right, I got that in there, is now I'm going to add my water. This is diluting it. So I'm going to add distilled water to the flask up to the 100 milliliter line. Okay, so then I'm going to fill, we'll pretend my water is red. We're going to fill all of this up with water. All right, so then what do I do next? I got to mix it. So cap and invert to mix. And then the last thing is that we want to make sure we have the right volume because our total volume should be 100. And sometimes when things dissolve, their volume things will get more compact. So the last thing is I'm going to add more water if below the line and mix again. So that is how you calculate parts of a dilution formula, how much, and then how to make a solution.